Hello everyone, my name is Mike Clark and I'd like to welcome you to today's DBA virtual chapter presentation. Once again, thank you for joining us today. Today's topic is on Weight Watchers, no pain, all gain. Exercises to increase our database performance. Something that's near and dear to all of our hearts is seasoned production DBAs. Today's speaker is Richard Douglas. Again, my name is Mike Clark. I will be the moderator. And today our sponsor is Dell Software. We'd like to say thank you to Dell for partnering with us here at the virtual chapter to help provide these online trainings. Technology is great and it does help us be able to do these kind of things, but it is not free. And Dell partners with us and allows us to provide these things free of charge to the SQL Server community. We want to say thank you very much to Dell. So the DBA virtual chapter is part of the parent organization called PAS, Professional Association of SQL Server. And there are many things in it. The whole organization is about SQL Server. One of the things that PAS has made available to us is a SQL Saturday. The SQL Saturday is an all-day event that's about SQL, as the name implies. There are multiple sessions throughout the day. Like for instance, right now we're having one session and then we're done. SQL Saturdays would have a session now, a session in an hour, a session in 2 hours, and so forth. And the larger ones have multiple concurrent topics for each hour, each session kind of thing. And so this is a little bit dated slide, but they're all over the world. They're here in North America for sure, and then there's ones in the international space. As you can see here, there were many of them on October 25th. It seemed to be a popular date, but Minnesota, Tampa, Salt Lake City for here in the U.S., and then internationally there's one in Sydney, Barcelona, Ica, and Rio de Janeiro. They're every month, almost every weekend, and if you go to SQLSaturday.com, you can see all the registered events as well as all the historical ones. And you can click on a current or future one and register for it, or see the current itinerary, who's going to speak, what are the topics, and then you can actually look at the historical ones and kind of see if there's a topic you want to get more information about as well. Quite many, most of those are recorded and online. Depends on the different areas, what they do. The session today is a virtual chapter. It's one of many. As you see here, there's plenty of them, from Azure to healthcare to in-memory database. There's even Oracle SQL, so you can interface between the two of them. There's language-specific, data architecture, all kinds. And so if you go to SQLpass.org, you can see all of those listed out there, and so your SQLpass.org is your starting point for everything SQL Server. The biggest training and event of the year is actual SQL Pass. That was just this past week up in Seattle. I was there. It was the 8th one I've gone to. It's actually quite nice. It was the best one yet. They keep improving. But if you missed that, you can actually go to watch the PAS Summit. They call it PAS TV. If you go to SQLpass.org and go to the summit, you'll see the PAS TV, and most of the sessions can be seen on the TV. On the online through SQL Pass TV. The SQL Pass organization is volunteer run, so everybody here does it out of the kindness of their own heart. And so if you're interested in volunteering, again, if you go to SQLpass.org, there's a My Volunteering section for registration. You can sign up and volunteer for any of the virtual chapters. Now, the one you're listening to right now is clearly the best one, but we would not be bothered if you went to a lesser virtual chapter and signed up there. Of course, I'm just messing with you, but there are quite a few good ones out there, and they can accommodate any level of interest and time that you have. So from many hours a year to just a few. And then we also give an outstanding volunteer award for those who do volunteer for the PAS organization, those who go above and beyond just normal stuff. There's a little award to kind of recognize that. There's a process to have that all happen. And then there's an International Passion Award that's handed out once a year at the summit. And that's nominated again by our peers, and the board votes and so forth, and then they make the final determination and make the announcement at PAS. So if you're, so that's the Passion Award. And so again, if you want to volunteer, just go to SQLpass.org and click on the volunteer button. And you get nice little awards you can put on your web page or your signature page or whatever, but these are the awards that we were just discussing. So stay involved. There's quite a bit to do with PAS. There's LinkedIn, Facebook, Twitter. There's so much to do SQL Server wise that it's hard to get your job done sometimes if you want to stay connected. So today's session, enough about PAS. It's a great organization, but today's session is not about SQL Server Statistics, I'm sorry, but it's about weight events, and Richard will be talking about that today. He's assistant consultant at Dell, where he specializes in everything SQL Server in their product range. He's worked with SQL Server for a very long time, since 7.0 till now. in various roles. He has a number of Microsoft certifications. He's a key member of the SQL Server community. He runs a local PASS chapter in the UK, and he serves on the organization committee for SQL Rally. And with that, I'm going to pass the screen over to Richard, and he will begin. Thank you, everybody.
Thanks, Mike. Let me just share my screen. Can you see that okay, Mike?
Yes, I see it fine.
Mike, can you? Okay, right, brilliant. Okay. Well, thank you very much for having me today. It's an honour to be able to speak at another PASS event. As Mike said, PASS is a great institution. I've been very lucky to be involved in quite a few different PASS events, be it SQL Rallies, SQL Saturdays, and you've spoken at the PASS Summit last year. So PASS is something that's very dear to my heart. I'd like to give you all a very warm welcome. It's evening, so it's actually pitch black, but it could be morning or afternoon, wherever you are in the world. So my name is Richard Douglas. You can find me on Twitter as @SQLRich. Now today we're going to be talking about weight statistics. So it's really going to be about performance tuning methodology, how weight statistics work, why they occur, how they occur, and how you can look these kind of things up with the native tools. So this is the introduction. I've kind of just covered this already, but these are the things that we're going to be looking at today. And because this is a sponsored session, there will be one or two references to some free products that Dell software provide, but they're really dancing, I promise you. So this is me. It's given me a good intro already, so I'll just leave this up for a second. Just to add that I do blog about SQL Server. You can find information about me on http sql.douglas.co.uk. If you've got ASP, do be very careful to wipe the dust off it. It hasn't been touched, hasn't been given a lot of love recently. You can also find Twitter as @SQLRich. If you want to email me to any follow-up questions at all, you can reach me either on the contact me page on my blog or richard.douglas@software.com. And I typically tend to put a lot of my sessions up on SlideShare.net as well. So if you go to slideshare.net/SQLRich, I'll be putting this presentation up and you'll be able to find a number of the presentations that I've put up there as well. So let's talk about weight statistics. So when I started from a Unix background, moved into Visual FOC Pro and then to SQL Server, and we didn't really have any Windows specialists, so trying to work out what's going on the Windows box was quite awkward, to be honest. We had no mentors or anything. You know, Google wasn't as it is now, so there was no just Google just this and get an answer. It was a case going to these hardback books. You know, this was a problem for us. So what we used to do was we used like a stopwatch, or there was at the bottom of your bar a query analyzer, as it was then. It used to tell how long things used to take in seconds, and that was the only metric we knew as to check how server performance was going and check the performance of our queries, seeing how long they were taking. Unfortunately, this is a really, really bad method. It's quite evil if you think about it, and to be honest, I even say that it sucks. So this is a real problem for us. Now my slide is moving forward. There we go. So what happened is we actually had an Exchange consultant come on site to look at a problem we had with an Exchange box, and I was lucky enough to be kind of guarding him in a server room at the time. And he had this thing up on the screen which kind of looked like this weird graph that you can hopefully see in my slide now. And I was mesmerised. At first I was a little bit worried he'd installed something without me knowing, and I asked, well, what's this? What are you looking at? And he told me all about performance counters, and it was a light bulb moment for me. You know, we didn't know anything about this. It was a brand new way we could look to see what our servers were doing, and then we found that SQL Server had its own performance counter as well. So you can not only look at this window performance, but you can look at what's happening for each SQL instance as well. So this had a massive impact on how we went about performance troubleshooting at this point. Now, moving on, in SQL Server 2000, Microsoft introduced something called weight statistics. Unfortunately, this methodology wasn't really highly advertised at all, and the information slide was a little bit sketchy at best. Now, we didn't have many weight types there. If you look at the right-hand side of the screen, you can see that only shipped with 78 weight types, which isn't a massive amount compared to the amount of performance counters that we had. So it's no real surprise that Microsoft weren't really advertising at this point. Thankfully, pretty much everything changed in 2005. There's a bit of a myth going around that no line of code was the sum between version 2000 and 2005. Some of the things that come to light with cardinality estimators in 2014 put that into doubt, but you know, it was a significant change. One of the things that brought in something called dynamic management objects, and this gave us a view into what was happening inside a SQL Server, and it massively opened up what we could do with weight statistics. Then in 2008, things improved again. We had something called extend events, which was a really lightweight way of looking at things. So in 2005, we had just the ability to see what was happening now in terms of weight statistics, and we had the ability to look to see what happened cumulatively since the last restart, or the last time SIRS was brought up. And so the ability to look into extend events gave us a lot more detail because we could kind of at a query level to see what happened at that query, and that was really, really powerful for us. Then in the later versions, 2008 R2, 2012, 2014, you can see that the amount of weight types that Microsoft have put into the products has massively improved. So we can see that we've moved almost tenfold in just 6 releases of having weight statistics there, and it's now really coming into the fore as a really great way of understanding what's happening in your SQL Server. Now, problem is that people still seem to sit in one camp, one or the other, weights or queues. So queues is the performance counter, and it's a problem that I do a lot in the field and also a lot in forums as well. So people tend to be jumping to the wrong conclusion from only looking at a subset of performance data available to them. So they're in the camp of like, yeah, performance counters have done me well so far, I'm going to carry on using them regardless. Forget the weight stats, so it's not, it's not there yet, it's not ready, it's not consumable. And you can have the other people that say, yeah, weight stats are the future, forget all these old counter stuff, they don't count for anything anymore, weight stats is the way to go. Now, unfortunately, they're both wrong. You need to be looking at both in tandem, otherwise you're going to miss things. Both can be quite misleading. So as an example of something that could go wrong, if I see high CPU usage in the form of a performance counter, say something like total percent used, or I have a high weight associated with some kind of CPU weight statistic, do I have a CPU bottleneck? It is hard to tell without correlating all this stuff. And the answer is possibly, but without taking a wider view of what's going on, it's very difficult to tell. In this example, it might be I've got high CPU utilization because I'm reading from disk so much, because my instances start from memory, or I'd have the right instances, something like that. So the high CPU values here are actually a symptom and not the root cause of the problem. Now, if I was just to look at one of these, either the weight, high CPU, or indeed the performance counters which show a high CPU, I might be tempted to add more CPU, which is great for Dell. You go and buy some Dell kit and improve performance. But this is only going to help to a degree. It's not going to eradicate the underlying problem. So I guess what I'm trying to say here is don't jump in with both feet first, because all you're going to do is end up breaking your ankles, and that's not a situation you want to be in. You're going to need some kind of medical attention, and you want the same kind of approach from your doctor. If you went in there complaining of constant headaches, you're not going to want him or her to just prescribe something to make it go away to mask the pain. What you want is you're going to want them to methodically go through and make checks to see what the underlying cause is, not to take that problem as gospel. So it could be something with your eyes, or mineral deficiencies, or any other kind of problem that it might stem from. What we need to do is to find the symptoms and not assume that what we're seeing is the root cause. And identifying stuff and correlating this information in SQL Server is no different to this. So when you combine these two things together, it's called the weights and queues methodology. So I've mentioned weight stats and weight statistics quite a few times now, and I've told you that they're potentially a really good way of finding a problem area. So the next step is to tell you how and why SQL Server uses this data and how it stores it. So to do this, what I'm going to do is I'm going to bring to one of my favorite constructs, which is the obligatory analogy. Okay, so I did rewrite this analogy a couple of weeks ago. We were actually on a family holiday to the Canary Islands. One of the islands is called Lanzarote, and unfortunately on day one I got really badly sunburned. Then the following day my son came down with tonsillitis, my youngest, so he's only 4. So we were kind of stuck in his hotel room, and he was kind of in and out of things with being so poor in the antibiotics and everything. So it gave me a great chance to think about what I was doing, and this presentation that was coming up that I actually did a week after when I came back. And what I decided to do was rewrite all this. Instead of using like the standard grocery checkout kind of analogies, what I wanted to do was to rewrite it around a common theme of travel, which is something that I hope a lot of us have had the fortune to experience. So in this example, we're going to be talking about my holiday and talking about going through security at an airport. So if you're not aware of this, so typically what you do is the security area of the airport before you board the plane or go to departure lounges is what you'll do is you'll queue up, and you'll queue up for one of 2 things, normally 2 things. There's a police scanner that you need to go through. You need to take off kind of coats, jackets, shoes if you're in the US, electrical and metal things at all. And these go in trays along with any hand luggage you've got, and they go through a bag scanner which basically kind of x-rays to make sure you're not taking through any forbidden items. So what I want to do is just kind of explain how this works in terms of weight statistics so you can identify with me as we're going through. So the first step of these three things is the queue. So I'm ready at this point. What I'm doing is I'm waiting to go through and be processed by the body scanner or by the bag scanner. So I'm waiting in this particular queue. Then hopefully I've got through the body scanner. As I've said, you tick off all the necessary stuff, put your things through. At this point I'm being processed. I'm a task, if you like, and I'm on this particular execution model, if you like, and I am being processed. I'm then being processed. The next thing is to go through the bag scan, and the same thing happens again. At this point, there's processing going on, and there's something happening. Now, if you're like me, obviously, if you're kind of like me, nobody is exactly like me, but you'll be taking through laptops and things like that. Unfortunately, 99 times out of 100, my stuff tends to go back because I've got so much things in there, where there's hard drives, clickers, all that kind of stuff. And so I empty it and it goes through again. Now at this point I'm ready, but I'm suspended. I've done all my bits, but I'm suspended waiting for something else to happen. So I'm in this suspended state. And then when I go back to processing again, once it's been done, and hopefully we can then go through and do some shopping or run for the airport. Plane as it normally happens to me, because Heathrow is an absolute nightmare. Okay, so hopefully it kind of makes it clear. Now what I want to put to you now is not all weight statistics are bad, okay? So there's a popular misconception, if you like, that you need to try and get rid of all weight statistics, but SQL Server chooses things in such a way, and I'm talking about parallelism here, that if you were to use parallelism, there's going to be some waiting time, but it's going to be faster than using just one thread. And so this is what this analogy is all about. So let's say we've arrived at our destination, we've got to a hotel, we've checked in, and the next thing to do is to go to our rooms. So we have a choice. We can either go up in the lift or the elevator, as I believe you guys in the USA, or we can take the stairs. And because this is a family holiday and my wife doesn't believe in packing lightly, there's no chance I'm going to carry all this luggage up the stairs. I'm going to wait for the lift. Okay, so at this point I'm ready. I'm waiting for this lift or this elevator to occur. The lift arrives, but unfortunately I'm in a suspended state because I can see another family coming in and I've got to wait for them to come on board. So I'm in a suspended state, as is everybody else in the lift. Thankfully the lift starts to take off, or go up the lift shift, I wouldn't say take off. So we're processing at this point. Something's happening, there is an action being performed. Now in SQL Server we would call it a runnable state. So anytime I'm talking about being processed or processing, this is the running view. So we're in a runnable state. So the next thing is, because kids in the lift are absolutely hilarious, they decide that they want to press every button possible. So this means we're going to be stopping at every floor. At this point, again, we're going to be suspended because we're waiting for something else to happen. We're ready, but we're waiting for a resource to happen. In this case, we're waiting for the door to open and close so the lift can move on. Eventually, we get to our floor, let's say floor 10, and we've stopped and everything is done. Now, does this mean that these weights are bad? Yes and no, to be honest. Now, what we could have done was we could have tried to remove or reduce the suspended wait times, and this would have meant that we had better performance, but would it have been faster not to have those weights and to walk up the stairs? Chances are, no, it's not. Even with those weights, there's no way I would have got all those luggage up there in a time comparable to following up in the lift, even with those weights. And it's the same thing for parallelism. So we're going to have multiple thread processing, but because of the fact that some of these threads might have a different data distribution on them, i.e. some run more records than others, at the end there's a very big likelihood that there's going to be a CX packet wait, and this is where some threads are waiting for the last one to finish. Now, it doesn't mean that this is taking longer overall than just running on one thread. This is something you need to test, and this is something I'm going to show you in the demonstration later on. So, there are a couple of things that we could have done to resolve this, but chances are that, waits aren't always a bad thing. You need to be cognizant of them, but they're not always a bad thing. So the next thing I want to talk to you was about the SQL OS. Now, at the point you're probably wondering what I'm talking about SQL OS. Now, Windows is the OS, Windows is the operating system. What's the crazy guy with the weird accent talking about? Well, SQL Server has its own operating system, and the reason for this is that Windows Server isn't a highly optimized system. It's great at what it does, but it was designed to all things to all people. It wasn't designed to do things really, really quickly, because that's going to restrict what people can do in certain scenarios. So, in other words, Microsoft built Windows Server to be a really stable and highly available product, but not to be optimal for every occasion. And it's kind of exactly the same thing when you look at cars. We have a choice between lots of things. So, Microsoft have essentially done what Volkswagen have done. They've given us a Passat when they have the technology to be able to go forward and create an Audi R8. So from the Windows side of things, we have good enough performance rather than absolute blistering performance, and all the smarts that are built in with that purely because they want lots and lots of people to adopt that platform and do everything they can. It means they can sell more stuff, and that's fine. So the SQL Server team realized that the limitations of what's happening. This is primarily around scheduling what's happening on the processors and also to do with memory management as well. So for 2005 they decided that they were going to write their own operating system which sits in a abstracted layer on top of the Windows platform in a cooperative manner, so that if Windows needs to do something, SQL Server will cooperate with that. So in SQL Server 2005 the SQL OS was born. Now there are a number of ways you can get further information on this. So as part of 2005 some dynamic management objects were created, and if you have a look at anything that starts sys.dm_os_, this provides an insight to what's happening into the SQL OS. Do go and Google Bing to have a look at stuff that starts with that. Go and find what's happening in Booksline. I'm going to be showing you a couple of things later on, but obviously we can't show you everything that's going to happen in the next hour. So I've got another example here, just to walk through actually what happens when we're trying to schedule time on a particular course, so you can see what's going on and how SQL Server works in this kind of scenario. So you might remember from my holiday in Atches that we've got three possible states. We've got running state, we've got runnable state, and we've got a suspended state. So I talked about processed and suspended and running. So we've got running, runnable, and suspended. So run is when a particular session ID or SPID has time on the core, logical core, and this is being processed. Okay, so that's our running state. Our suspended state is when we are waiting for a resource. So this might be a lock, it might be a page from disk, it could be lots of different things. Okay, but that's going to be our suspended state when we're waiting for a resource. Our runnable state is when we have all the resources we need, we just don't have time on the processor because something else is on there. And so remember, this is talking about a single scheduler, and each scheduler is tied to a core, so each core has its own scheduler. Okay, normally you're going to have a minimum probably of 4, maybe 8, 16, 32, 64 cores on your box these days. So this is a very simple example, just showing one core. Obviously you need to extrapolate this out for the number of cores that you have on your systems. So in this sample we have session 55, which is running on the scheduler, and what's going to happen is this session or this SPID is going to need to move across, basically because it needs to get something from disk. So in this example, it's requesting a latch from page that's on disk, and it's going to be a shared latch. So the wait type that's being presented back to us from SQL Server internally is paid.io latch sh. Okay. So this means because this has moved over to the suspend queue, that nothing is running. So what's going to happen is something is going to be taken from the runnable queue and it's going to be pushed into the running queue. So SQL Server will manage the runnable queue, and it will put up to the top of the list whatever it thinks is going to be the best in terms of producing more concurrency for its users. So this is an advantage of having a SQL OS rather than a Windows OS, which would be a first in first out kind of scenario. In this scenario, SQL Server can manage what's in the queue, so that we have less blocking, that kind of good stuff going on. So in this scenario, 60 is at the top of the list, 60 is going to move on to the running queue. So we're moving around slightly. Let's say 60 is then complete, it's had its time, it's finished the task, that's going to move off. The next thing in the runnable queue is SPID 65. SPID 65 is going to push up and it's going to have its time on the core. Let's say for simplicity, at exactly the same time, SPID 55 has its resource now, it has this page from disk. SPID 55 is going to go into runnable queue, 65 is going to toggle off and send its information back to the client, and then session 55, the one we started with, is going to spend some time on the main core. Now, in the last few slides, I've seen some pretty simple examples of how things worked, and I wanted to introduce another concept at this point, and it's called the quantum. Okay, so there's a kind of charged reason for adding this and a serious reason for adding this. The charged one is that I like to add film titles, and having the concept of Swiss on the slide is quite amusing for me, but I do this kind of stuff. But also it does relate to SQL Server in a very good way. So the time that something is spent on the scheduler, on the core itself, is limited, and this is called a quantum. So each thread will only have so long on each core. I can see this inside of SQL Server. So if you're looking at the slide now, you'll be able to see that I'm doing a query on sys.dm_os_schedules, and it's telling me what the quantum length is. I can also see what the scheduler is and what CPU that scheduler is assigned to as well. So what can happen in SQL Server is you can have processes that will take a lot of CPU time, and so that things run nicely in a nice cooperative manner, SQL Server is going to say, you have this allotted time or this quantum, and once you've exceeded this, I'm going to kick you off and you're going to go back onto the rebel queue and you can have some more CPU time once we've said that other things had a chance to run. Now, one of the reasons for this is that a lot of background tasks that SQL Server has that are only CPU dependent, which means it's got no chance of being suspended because it's never going to need some other resource. And so it's one kind of reason why the quantum's going in there, and it's of solid to us that quantum is in there. Just as an aside, I can't see questions at this point. If you do have questions, do add questions in on the Q&A on the side, and we'll answer those at the end. So viewing weights and statistic information. So there's a couple of different ways that you can do this. The main way that people tend to do this, and they do this because it's free, is you can look dynamic management views. We're going to have a look at some of these today, and I'm going to show you some queries. I'll post on my blog the queries that I'm using so you can pick those up. Extended events is another one. Because weight statistics is such a huge subject on its own, I'm not going to have a chance to cover extended events as well. If there's something that you think you would like to know about, do drop me an email. If there's enough people, I'll create a session on this. It might be that we do on a past session, or it could be that something Dell does. Also third-party tools, as I mentioned before, I do work with Dell software, and we've got some great tools that give greater insight and greater granularity than the native tools do. There's some exciting work happening in this space. There's a new version of Spotlight coming out in a couple of weeks, which really blows things out of the water in terms of weight statistics and what we can share with those. So do have a look at software.dell.com/platform/SQL Server to have a look at some of the solutions that we provide. So going into what we can see with the native tools, there's a command called dbcc SQL perf. Now, if you use SQL Server 2000, and I was speaking to a guy just yesterday who said he's had 50 instances of it. I felt so sorry for him. 50 instances of SQL Server 2000, that's a horrible place to be in. So he wanted to look at weight statistics. This is the only command he would be able to use. Now, it is backwards compatible. I will still be able to use this in SQL Server 2014, and to be honest, in preparation for this session, that's exactly what I did. I used it to make sure that it worked. Now, what it's going to do is show you all possible weight statistics for your edition, even if they haven't been used. And it's great for testing out new versions of SQL Server because you can see the new weight statistics that are available between your version and the version you're moving to as well. So even though you might not be using those particular things that break those weight statistics in your environment, your testing environment, you'll know they're there. So when you come to add in extra functionality, you're going to know that you're going to be able to pick up that kind of stuff. Also, on the side, you can clear the weight statistics down using this command as well. So if you use dbcc SQL perf sys.dmos weight stats clear, then this is going to clear this down. This is a very important thing to note here. So this is using a DMV. This clearing down. So if you're using a DMV at any point, you need to be aware that this typically is transient data. This is data that's stored in memory. It's not persisted to disk by default, which means if you restart your server, you're going to lose this information. If your server goes down, you're going to lose this information. If somebody runs this command, you're going to lose this information, okay? So you need to be undertaking deltas of this information on a regular basis if you're going to be rolling your own solutions. A couple of other things to look at. There's another view called sysdm exec requests. I'm not going to spend too much time on this because we're going to see it in the demo. Do come back and have a look at it on slideshare.net/SQLRig, and although there's going to be the replay, this is going to be available online through the PARS site. Another one to look at is sysdm OS weight stats. Again, we're going to be talking about this in the demonstration, so I'm going to kind of gloss over it. One thing I do want to draw your attention to is the big red writing at the bottom, and this comes direct from books online. It says, in SQL Server, the wait time counters are big int values, and therefore are not as prone to counter rollover as the equivalent counter in earlier versions of SQL. The first time I read this, I got a nice warm fuzzy feeling, partly because I was sitting next to a radiator, but maybe because I saw, we fixed something, and then I read it again and saw, I'm not as prone. So there's still a problem, and it kind of goes back to the fact that if you've got systems that are running for a very long time, these kind of values will spill over and will start again. This is something that I've seen on a previous version of SQL Server where they use smaller data types, not for this particular DMV, but for other DMVs. And it can cause you a problem if you are using these to do your performance troubleshooting from. So I do implore you that if you are using native tools, you create your own tables and create deltas of these and store them in regular intervals, and then you're going to have to create some complex queries to bring all this information back together again. But chances are it's going to be more relevant to you and you're going to be making the wrong decisions based on bad data. So the next one we're going to be looking at, and the kind of last one in the list, is this DMOS weighting task. It's kind of similar to some of the others that we've looked at. It turns real-time information. I'm going to show you more in the demo. Deciphering weight information. So I just need to copy. So these are a couple of the more well-known weight statistics that we have inside of SQL Server. So the first one is the page IO latch. I showed you this in the scheduler analogy, or the slide to show how all the schedules worked. And so this is a latch on memory while data is being pulled from disk. So there are a couple of different ones here. You can see whether there's an asterisk, it could be SH, UB, EX, there's a couple of others. So basically shared, update, or exclusive blocks. The same kind of things applicable for page latch. The difference here is instead of getting it from disk, it's already in memory, so we'll take a latch on that. CX packet weights, I've kind of covered this already when we talked about query parallelism. Don't worry if you don't understand it fully. I'm going to have a demo on this in a couple of minutes time. Big red text, let's read this out. So as a reminder, you really need to correlate weight statistics with performance counters. You can't take each one on its own. You really need to look at them in tandem to find out what's going on. Both of them could give you a different story, a different idea of what's going on, and it's only really by correlating all the information that you have that you're going to get to the right conclusion for your problems. Okay, so if you're not aware of performance counters and how they sit together and some suggested thresholds, I did do a presentation called The Day After Tomorrow, what you need to baseline. It has got some thresholds in there that you want to look at as a first line of defense kind of thing. These kind of things do depend on the environment you've got. Some are going to be way out, some are going to be spot on, depending on the hardware they've got, to be honest. And you can find that on slideshare.net/SQLrich. I also recorded it for the SQL rally that were done last year in Stockholm and in Amsterdam. I was lucky to speak at both those conferences. If you remember my intro slide, the actual image was me doing this presentation over in Amsterdam. So I believe both those are on YouTube as well, so you can search on YouTube and have a look to see more about performance counters if that's something that you're not aware of. So some more common weight types, the SOS schedule yield. So we talked earlier about quantum, when things get kicked off of the CPU. When this happens, you're going to see this SOS schedule yield weight type. Write log is quite common again, normally when you've got slow I/O systems, but not always. And this tends to occur when you've got slowdown writing the transaction information to the disk. Okay? And the other really common one is locks, so LKM, whatever, could be a shared exclusive. Lots of ones in there, intent shared, intent exclusive. This is just where it's waiting for a lock to happen. If you're interested in knowing the difference between locks and latches, a big shout out here to Matt Broadbent, who was recently nominated for the Passion Award at the Summit. So he didn't get in, but he created a great blog on there about all the different levels of concurrency and things. So do go to tenballs.co.uk and have a look at how they all interact with each other. Gives you a much better understanding of how locking works at that point. There we go. I thought my machine had hung there for a minute. Okay, so what we're going to do now is going to dive into a couple of demos. So let's see. Can everybody still see my screen? Hopefully Mike or Scott will be able to shout out to me.
Yeah, I see it.
Okay, perfect. Right, okay, so what we're going to do is I've got a project here. Let's just open this one. So this is simulating what you would need to do in SQL Server 2000. So on all the boxes that I control, I tend to create my own kind of MDB database, and I like to call that DBA control. So the first thing we're going to do is I'm going to show you what this looks like. So if I run this, it's very simplistic in what it returns. We've got a couple of columns. We've got our wait type, we've got the number of requests, we've got the total wait time in seconds, and we've got signal wait time. So signal wait time is the time waiting for the CPU. So this is the amount of time in our runnable queue. Now if we wanted to find out what the resource wait time is, it's going to be signal wait time minus the signal wait time. So what time is all the waits put together? Signal wait is our time waiting for the CPU. So therefore, resource wait time is wait time minus signal wait time. Okay. So you're going to want to put this into a table, and you're going to want to do various things with this. So I'm going to simulate this here very, very quickly. I'm just going to insert into my table using the sp execute SQL command, because I'm calling a dbcc command. I can't just do insert into. that's inserted some records. It does insert a row that is total, so if you're in any kind of aggregation and things, you're going to want to get rid of that. And then what you can do is you can then simply look at the data, you can do your groupings or whatever you might want to do, work out the averages and all that kind of stuff. So it's a very simple way of finding out what's happening if you've got SQL Server 2000. Moving on to 2005 and above, we obviously had a dynamic management object brought in. First one I wanted to talk about was DMOS weight stats. So in its very simplest form, this is what it returns. You can see it gives a little bit more information. We've got our wait time, our wait type, our task count, so the number of times this wait type has occurred, the wait time in milliseconds, so slightly different from the last lot. We've also got the maximum wait time, so this gives us a good indication of was this a one-off problem or is this an ongoing problem? That's something that was missing from the DBC SQL per command. And we've got the signal wait time again. So it gives us a little bit more information. It's a bit more meaningful, obviously, because we're 2005 and above, we do have more wait statistics to choose from, as opposed to 2000 systems. So because it's a dynamic management view, what we can do is we can join this to other things, and we can also do lots of other nice things like add in ranking functions. We can cast all this other stuff in as well from the initial query without having to create tables and things as well. So what I can do is I can then go through and I can order things in a much simpler way. So I can say in this scenario I want to look at the rank which is based on the wait time descending. So I've got my rank here. And if I was just looking at the amount of time spent, then I might think that this is my biggest hitter. It's not, but it depends how you want to rank these things. If you want to rank it by the average and all this kind of stuff, there's lots of scripts on the internet that can help you out with this. Another one to look at is our waiting tasks. This helps you to find out what's running right now. Okay, so before the DM wait stats was showing you cumulative. This is what's happening right now. So the cumulative, everything since the last restart or the last time the counters were dropped and recreated, and this time this is what's happening now. For this session, I have a wait duration of that many milliseconds for this extended event wait type. So you can see what's happening in real time. And this can be very, very powerful. Especially when you combine it with other dynamic management objects. So I've got my waiting tasks. I'm going to look to see what requests are happening. I can then link my requests to my session ID, and from that point on I can say I just want to look at what's happening now for user processes. So I want to exclude anything that's happening at the system level. Now I don't have anything running on my box at the moment, so you're just going to see a suspended select. It's running some trace in the background. But you can kind of see the power of this if I did have lots of things running. So the next thing is for us to have a look at what's happening when we do have lots of things running. So I do have a temp DB contention script. So let's start that up. So what I'm going to do is I'm going to simulate 100 sessions running on my box. They're all going to be creating temp tables, dropping temp tables, inserting some records into them. So what I'm going to see is I'm going to see some contention on temp DB. Now before we start this, I just wanted to show you how my temp DB is set up. You can see that I have one data file and I have one log file. You can see that we have a database ID of 2, which is always going to be associated with temp DB. File ID 1 is always going to be data. File ID 2 is always going to be our log file. Now, it's typically a good idea to have more than one data file. I will go into this in just a second. Okay, so what I'm going to do is I'm going to create a results table. And inside of this results table, I'm going to insert some data. So this is exactly the same query that I ran on the last script. So this time we're going to see a lot more information. So we can see here we have 97 rows. And what I'm going to do is we're going to view the data. And what I want to do is to show you the contention that I'm going to see or that I expect to see. Hopefully it's going to happen. If not, we'll have to sacrifice an Oracle DA or something to the demo goods. But what I'm going to do is I'm going to show you the wait resource, the wait time, the schedule ID, and the session ID. That's how it's going to be ordered. And hopefully you should see a very interesting pattern. So here we can see the suspended state, we can see the kind of command it is. We can have the SQL handle. If we have the SQL handle, we can also get the plan handle. We could potentially pull in the query plan here using one of the other DMVs here, sorry, DMOs. But what I wanted to show you was we can see the wait type, the wait time for this wait type for this session, and also the wait resource. Now this is where wait statistics gets very, very powerful and does have to not over performance counters, because I can see what page the resource is waiting on, okay, that we're waiting for. So this wait resource here in this format tells me 2:1:1. This means the first one is the database ID, so database ID 2 is tempD, file ID 1, that's my data file, and page 1. I can see lots of these here, and I can see some other going on here as well. So I'm seeing lots of intention on 2:1:1. This particular page is a system page. The system page is something called PFS page, which is page 3 space page. Now this is got its own bottleneck on it, and what we could do is we could create more data files, which means we're going to have more copies of this page for a space file, which are going to alleviate contention. Now, if we're going to go through and work out some of these other ones, we're going to see that some of these are also going to be system pages as well. So again, by scaling out the architecture that we have, we're going to have less contention on these individual pages. I need to look at what these ones are using. Some of the DBCC commands, DBCC page, for example, to have a look at the page type, but it's going to be fairly safe bet that some of these are also going to be system pages, and if I was to scale these out, then I'm going to get rid of some of this contention. So you can kind of see how this can be so important to identifying where wait resource is. Now, the other side of things, of course, is that you could refactor the code so it doesn't use temp tables, but this is where the whole thing comes in, of having the 50,000 foot view and seeing everything that's going on. Okay, 6 packet weights. So the next thing I wanted to talk to you about was 6 packet weights. I've got a couple of demos here on how these work. So what I'm going to do is I open this one, and let's run this other simulation. So I'm going to run 5 clients. It's running a query, obviously. I'm just going to show what this is doing. So I'm going to turn on Flask. That's very important. You'll see why in a second. I've got a custom database here. I'm going to clear down the statistics, and I'm going to show you the query that's running all these other sessions. So if we execute this now with actual plan on, not really important data there, it's all a bit of a mishmash of stuff, but I want to show you the query plan here. So depending on your screen, you might not be able to see this. This icon here, with the yellow symbol here, means there's parallelism happening, which means we're going to be using multiple cores. Okay. Now, SQL Server will use parallelism if there is a certain cost threshold that is reached. Now, we can see this cost by right-clicking on, by hovering over our select option icon here, and we can see that the estimated subtree cost is 5.7. Okay. Now, the threshold SQL Server is 5 by default. And if I show the properties here of this icon, click on actual rows, we can see that these are the thread number of records or number of rows that are worked on each of the threads. Now in this box I've got 4 cores, or it's pretending to have 4 cores anyway, and you can see data distribution that's happening between these. You can see that these aren't even. This has got 57,000, so this has got 57,000 here, and this has only got 18,000. So what's going to happen is that thread 4 is going to finish way for this one, which means as this is waiting for this, lots of CX packet weights are going to be building up. Now, it doesn't necessarily mean that this query will be faster if it only ran on one thread. This is something that we can test, and some other scenarios I'm going to show you as well that you're going to want to include rather than just go for max DP equals 1. So let's have a look at some of the things we can look at. If you go to sys.configurations and have a look where the name is like cost or like degree, there are 2 options we can look at. The cost threshold for parallelism, as I mentioned, if there's a query with the cost threshold, the cost of 5 or more, it will be considered for parallelism. Every query can be parallelized. The optimizer will try to optimize it. The next one is max degree of parallelism. This is to say, how many cores am I going to try and use? Now, you can see that I was using 4 cores there. Naught doesn't mean I'm going to be using naught. Naught actually means unlimited. We still wouldn't do that, but that's how I've chosen to implement this. What was apparently I have 32,000 cores, which isn't true. But there has to be a limit somewhere. So one of the things we can do is we can go through and change some of this information. But before we do that, what I want to do is I want to show you a script by Paul Rundle. This is taken directly from one of his blog posts, Weight Statistics, or Please Tell Me Where It Hurts. Do go and have a look at it. Paul is absolutely fantastic. I've been lucky enough to go to one of his immersion courses, and the amount of stuff that him and Kimberly know is absolutely unreal. all this stuff in red is a weight statistics that he believes are weight statistics or weight type categories that aren't really beneficial for you to looking at this kind of benign weights, if you like, they're only going to happen at the system event. So if you're not really going to want to try and troubleshoot these unless something massively drastic is going on. We've created a really big query that looks at the weight statistics that take up 95% of the weight, and then says, let's have a look to see what's happening there. So we can see that CX packet weight's quite higher here. You know, we had over 9,000 occurrences of CX packet weight. We waited for a total of 197 seconds during the sample, 197 seconds of CPU time during that sample. So what I want to show you now is what happens if we go through and we reconfigure our cost threshold. If I change the cost threshold to 50, bearing in mind this is an instant setting, so this means that every plan will need to be checked against this threshold, and you know, this is going to change if it's parallelism or not. Let's run this query again on its own. Have a look at the query plan. We can see here that this icon has changed. It no longer has the yellow circle in which denotes that it's parallelized. And if I have a look at the select, we can see that it's 5.58 in terms of cost. So it's above the original, but it isn't above the new threshold. Therefore, it hasn't been chosen to be parallelized. Right. So what I'm going to do now is I'm going to use our wcc command to clear down our weight statistics. I'm going to go through, I'm going to run this again quickly. We go through and we run this, not to be a very scientific test, but if we go through and then we start running this, it's not finished yet, but you can see there's no CX packet weights there, and the reason for that is that we've got rid of parallelism by moving the thresholds. So a lot of people, what they'll do is they'll change max DOP and say it should be 1, you know, just get rid of all CX packet weights, but what about queries that really need it? If you think about Moore's law, where it said that, you know, technology moves on in an incremental way, I can't remember what it is now, but it moves on, and hardware has moved on so much faster than the code base changed within SQL Server. So this cost threshold of 5 was based many years ago, and our hardware has improved, you know, significantly since then. So what we really need to be doing is we need to be changing our threshold. Otherwise, we're going to have very low-hanging queries that really, you know, shouldn't be using parallelism, but are, and that could be increasing the amount of CX packet weight that we are seeing on systems. So the next way that you can do change things is to reconfigure the max degree of parallelism. So as I mentioned, I've got 4 cores. What I can do is I can say I can set this to, so this means that if I do hit parallelism, I'm only ever going to be using 2 cores at the same time. What's this going to mean to me? It means if I've got big queries that need to have parallelism, I can run 2 of these at the same time, which means I'm going to have better concurrency. Now, you know, you need to test it in your environment. I'm just saying it's an option for you. Okay, I'm not saying this is something that you must do. So let's make sure that I run all these. We'll go back, we'll run our test again. And again, what I'll do is I'll make these scripts available, although you need the database for this one. That database is scripted, and you can find that on my blog actually. So if you run this query, we should see that we have our plans on. And if we have a look again, you can see that we have the parallelism operator in there. If I right-click on it and choose properties, I can have a look at the properties to see what's going on. And again, I can see the number of threads here. Excuse me. Apologies, we can see the number of threads here. We can see that it's only using 2 threads instead of the 4 that we had initially. And so another way of potentially reducing the amount of CX packet that we're seeing. Let's just check that. If I go through and I run this query again, the CX packet weight is up there. Normally what you would see is the weight count, so you would see the weights in seconds reduced compared to it was, because we're able to run more of these concurrently, therefore we're seeing less weights, okay? And this will be something that you'll be able to simulate in your own test workloads. So that's all the demos that we do have time for because we're almost at the end of the hour. There is something I wanted to show you very briefly, and you probably saw it in the background. This is Spotlight free edition. So we tend to get our freemium edition, and this is a Management Studio plugin. So what you can do is you can go to spotlightessential.com, And you can download this for free, and what it's going to do is it's going to show you some insight into what's happening in SQL Server. So I've mentioned about the waiting queues methodology, and that's what this free tool provides for you. You can see the queues in terms of what's happening with things like CPU, our I/O going on, our batch requests, all the good things. And you can also see what's happening with wait statistics. So you can see over here when I ran my first demo, there was lots of latch contention. So this is when it's running my temp.db. We can have a look and see what's happening with statistic in a little bit more detail. And it's going to tell me all about what's happening for some of these weight statistics here. Now, if you did want more information about weight statistics, then we do have the free edition Big Brother. You can go and upgrade to the Enterprise edition, which is a paid-for version. I'm not going to labour about the point now. Do have a look at the Spotlight Essentials plugin. As I mentioned, it is free. It's going to be completely free, and there's a free trial for Enterprise edition for 30 days as well. So I do hope you take us up on that. So if we go back to the presentation. Here's some of the products that we do have. I just wanted to put that on screen because it is a sponsored session. If you do want to talk to me about any of these kind of things, then do give me an email at richarddouglas@software.dell.com. I'd also like to do a bit of a shout out for our new SQL Server Resource Center. So this was only released a couple of weeks ago, just for the past summer, I believe. And this is kind of a one-stop shop for us. So what we've done is we've put all of our recorded Dell SQL Server webcasts in one place, program demos, product demos. It's also SQL Server educational webcasts such as this one. On there, there's white papers in a white paper in their top 10 for optimizing SQL Server performance. There's some use case studies and lots of other things that we think you're going to find interesting, infographics and stuff like that. So please do have a look at that as well. And I'd like to open up for questions now.
Okay, Richard, thank you very much, sir. That was a very good presentation. I enjoyed it very much. We have a couple questions here. Okay, sorry, I thought I scrolled. I'm sorry, I'm having. Anyway, so the question I have is, what is the address for your website to get some of these scripts? Some of them I know will be packaged up and on the SQL, the dba.sqlpass.org website. But you also provided another website, your local one. What was that again, just for those of us that want it?
Yeah, that's right. So my website is sql.richarddouglas.co.uk. I'll just stick our contact details.
Okay,
yeah, so that's my blog. I'll post a couple of blogs in the next couple of days on there showing some of the scripts. My blog is also syndicated on Toad World as well, which is the Dell SQL Server community site. So if you go to either of those places, you'll be able to pick it up.
Okay, great. So another location as well, folks, for today's scripts will be at dba.sqlpass.org. In the intro, we mentioned sqlpass.org a lot. If you go to there and click on the DBA section, you can get these downloads as well. A question about the Spotlight plugin is, does that edition require server components to be installed before it can monitor a server?
No, so it's completely agentless. It will sit on your desktop. It will install a repository on your desktop, and then you point at the servers you wish to monitor. So it basically just polls, send requests to the server, brings the information back. That information is then logged locally on your machine, and then that's it.
I see. Just as a side note, the question interface shows the asker. And the asker for that particular question was London DBA, so I thought I'd share that with you today.
Oh, wow, okay.
Yeah, so it's like, oh, that was interesting. So there's been a couple questions. Before you mentioned about the guy from England who was nominated for the Passion Award in his presentation on Latch versus Lock, his blog. Can you state that again for those who want to hear it?
Yeah, so there's a guy called Mark Broadbent who's in UK. He runs the Cambridge virtual chapter, Cambridge Pass chapter, runs SQL Saturday in his current regional mentor. He has a website called 10bulls.co.uk. So that's TENBULLS.co.uk, and he's got a very nice grid that tells you all about concurrency and which locks and latches play nicely together. It's real help in identifying where problems can be. I think he's also done a couple of sessions on locking as well and concurrency. So there'll be blogs linking to potential recordings, I guess, somewhere on his blog. I think it was recorded on SQLbits.com as well.
Okay. So I have a question for you. Is someone said they recently upgraded memory for the SQL Server running on the VM, but now the PLE has decreased. That's the question. I guess he's wondering why would that be the case.
So the PLE, the page life expectancy, decreased when they've added more memory?
Yes.
What's that question?
Yeah, that is a question, I believe. Yeah.
Page life expectancy has decreased, and the only change was going onto a virtual machine.
That's all we have to go on. Yeah.
Okay. It sounds like something else has probably happened at the same time. Maybe an index has been removed or something like that at the same time, which meant that the cache is being thrashed at more than it was. Adding more memory is generally going to increase the page life expectancy rather than decrease it. But this kind of really where dog weights and queues methodology comes in. So you can be looking at counters, you can be looking to see what else has happened in conjunction with a baseline. So I mentioned the baselining talk they did. So this way really you need baseline so you can see what's changed between the two segments of where you are now compared to where you were then. Is there anything else that's changed? Has your I/O latency gone up? And all these other things that you potentially should be looking at in conjunction with PLE, not just fixating on one particular counter, but seeing what could be a cause of memory retention. Is it that you have massive fragmentation in the indices? Is it I'm seeing tension elsewhere, which is causing more memory to be required? Am I doing more scans? Has somebody implemented something which means my queries are no longer saggable? Therefore, I'm trying to bring more data in. Am I reading more data than I used to? All these kind of questions of things need to be answered to form a hypothesis of what the underlying cause could be.
Okay. Yeah, concurrency is always a hard thing to pinpoint, especially on a VM.
Yeah. And that's, if other things, another database is stuck on there as well, another application or another site come online for an application. We've had that before, where sites just online and you've been told about an extra 200 users, and then you're wondering why something running slowly. So something will change. It might not have been an architectural thing. It might be a business requirement that's changed. Maybe more data is put in. Who knows? You need to find out what these differences were, and that's going to help you to rule things in and rule things out.
Yeah, and today's session will help immensely to help pinpoint some of those issues as well, so good timing. Another question, again from the London DBA, is does the System Health Extended Event Session have any info on weights?
Oh, I'm trying to think now. There are a couple of blogs that tell you exactly what is in there. I don't know off the top of my head. The later ones I think use extended events, so it's possible that there are some information in there, but typically you're going to be grabbing this stuff from the dynamic management objects that I mentioned. There's also something called the management data warehouse that you can use if you've Enterprise Edition, which will collect information for you, and you can have that as a repository. It's a fairly expensive thing to implement because you do need the Enterprise Edition there. Yeah, it's something that I'd need to look up, to be honest.
Yeah, the System Health, if you're talking about the default extended event trace, that's supposed to be pretty lightweight and small, so it won't have a lot of detail in there, but I'm like you, I don't know exactly what's there, but it's going to be just big time issues, not normal operational things.
I know it covers deadlocks and things like growths and stuff like that. I don't know if it really goes into the depth of having these other things now, because it would be a case of creating some filters and it's already being cooked by the DMVs.
Yeah. Okay. Well, with that, Richard, I'd like to once again say thank you for presenting today, and I want to say thank you for everyone for attending, for being engaged and asking great questions. It's always a timely thing to understand what our system's doing and the performance on that. So I appreciate it very much. One of my favorite quotes, I just have to say this, is when you're talking about the lift. My wife is on vacation and she doesn't believe in packing lightly.
Yeah.
Yeah.
Yeah, I lost about half my suitcase.
Yeah. Yeah. So with that, again, I'd like to kind of say thank you very much. One of the things that we're able to do, a fun thing we're able to do with the DBA Virtual Chapter as a result of having Dell Software be a partner with us is we are able to give out a small raffle prize for at each session. And so today is Mikhail Kimmery, and we'll be sending her Amazon electric gift card or e-card today after lunch, West Coast time. So we appreciate that. And with that, I'd like to say thank you for everybody, and we'll see you in 2 weeks.